A slinky is a toy pre-compressed helical spring invented by Richard James in the early 1940s. It can perform a number of tricks, including traveling down a flight of steps end over end as it stretches and reforms itself with the aid of gravity and its own momentum, or appear to levitate for a period of time after it has been dropped.
Hey guys, today we'll be conducting an experiment with slinkies. We'll be investigating the effects of gravity on the slinky, whether if the degree of inclination of a plane will reduce the time taken for the slinky to walk down the plane. Without further ado, let's get started. In this experiment, you will need
A slinky, a plane, a spirit level, two 1-meter rulers, two long retort stands, a stopwatch, a marker.
Now that you have gathered the apparatus, let us set up the experiment as shown in the figure.
Procedure. Step 1. Set up the apparatus as shown in the figure. Step 2. Mark out a starting point on the wooden ramp with a marker. Step 3. Measure the distance, the d hypotenuse, from the start point to the end of the ramp and the vertical height h from the starting point to the ground using a meter ruler. Step 4. Pull the slinky apart, making sure that there are 20 coils at the end of the slinky nearer to the starting point. Ensure the distance between both ends are the same. Step 5. Upon releasing the slinky, start the stopwatch. Step 6. Count the number of times the slinky flip. Stop the stopwatch once one end touches the floor. Step 7. Repeat steps 5 and 6 to get a second reading and calculate the average time taken. Find the angle of elevation, theta, using trigonometry. Record the data in a table. Step 8. Repeat steps 4 to 7 using different vertical heights h.
So what are some safety precautions that we need to consider? Well, number 1, we need to ensure that there are no fragile items while conducting the experiment, as accidents can occur due to the slinky's unpredictable movements. Number 2, do not swing the slinky as it may hit someone. Number 3, place 2 rulers beside the ramp to ensure the slinky does not flip off the ramp. Number 4, use vertical height to find the angle of elevation. Theta through trigonometry is more accurate than to measure the angle of theta directly using protractor, as the percentage uncertainty when taking the reading directly is high.
We believe that as the angle of inclination increases, the time taken for the slinky to perform a work decreases.
Audio Jungle.
So the reason why such a phenomenon occurs is because as the angle of inclination increases, the normal reaction force that is perpendicular to the surface of the plane decreases. As the component of the force perpendicular to the plane decreases, the component of the force parallel to the surface of the plane increases. For example, take weight of slinky to be W. As angle theta tends towards 90 degrees, the value of W sine theta tends towards W. Hence, a larger force translates to a greater acceleration, and this means that the time taken for the slinky to travel between flips decreases as the final speed achieved will be greater. Since the slinky is an elastic spring, when given the initial stretch, it travels down the plane by a series of compressions and stretches. In conclusion, the change in vertical and horizontal components of the forces will result in different linear acceleration. This explains why when the angle of inclination increases, the time taken for the slinky to travel between flips decreases. This can be further applied into real life. This explains why as heavier weights are required to move an object on an inclined plane. The more inclined the plane, the heavier the object hoist will be in order to pull the other objects up.